Okay, students. So you're familiar with matter. Anything that occupies space and has a mass is matter. We have discussed that before also. And you all know the matter exists in different physical states. The solids, liquids and gases. In addition to that, there can be changes in the state as well as different changes can take place to matter. So in this lesson, we are going to focus on changes occurring to matter, and to understand that we are going to do this activity. So we will look at some examples where changes take place in matter. So to start the activity, I have naphthalene balls, or what we call as mothballs in common terms. You can see the mothballs here. Now you know this is a white color pebble-like or pellet-like structures. You have used this at home. Now if we take the mothball, we leave it in a place for about few weeks, you won't see the mothball anymore. What happens there? The mothball goes into a different state. Now here the mothball is in the solid state. It can go into the gaseous state. So here in this activity, what we will be doing is, I will take a spoon, I will heat the spoon, and then onto the spoon, I will put the mothballs. So for the heat of the spoon, you can see what happens to the mothball. Thereafter, I have another spoon with which I will cover the first spoon containing the liquid mothball with the second spoon. Then you can see what happens there. Right. So we will need to first heat the spoon. It has to be heated strongly. So I will hold it for some time so that it becomes really hot. In these students, now if we put the mothball and heat the spoon, then of course there is a high chance that while in the flame itself, the mothball will vaporize and it will enter the atmosphere. So we won't have anything remaining in the spoon. That is the reason why we need to heat the spoon first and then put the mothball after removing the spoon from the flame. So I have to make sure that it is heated strongly. So that's why I'm holding it for a longer time. So students, it should be enough heating of the metal spoon, so I can take it off, and before I put the mothball, I'll make sure that I turn off the Bunsen burner. There is a chance that the mothball can catch fire. So to prevent that, it's better if you turn off the burner. Okay. So now students, it's a hot spoon. I'm going to put the naphthalene ball onto it, mothball onto it. Observe it. You can see it becoming a liquid. Can you all see that? And you can see the fumes going off from there. So this is what we need to do. I need to close it with another spoon. So here you all can see it becoming liquid. The solid turning into a liquid. We will have to hold it for some time. Now you all can see now the mothball has almost disappeared. Only the liquid naphthalene is there. So I will hold it like this for some time. You will have to hold it for quite some time so that the vapor that is going off from the naphthalene gets condensed on the other spoon, the second spoon, because the second spoon is cooler than the first spoon. So now here students, you all can see the shiny solid substance at the edges of the spoon. So what happened here? When we keep this aside also, you all can see the changes taking place again. At the same time, you all can see the shiny substance, solid substance on the sides of the spoon. So what happened here? Initially, this is the solid naphthalene or the mothball. Then when I put it onto the hot spoon, the solid mothball or the solid naphthalene became liquid naphthalene, and thereafter from the liquid naphthalene there were vapor of naphthalene escaping because of the high temperature. When I closed it with the second spoon, vaporized naphthalene again became solid on the spoon. So it condensed not to a liquid state, but it solidified. The naphthalene vapor solidified on the spoon. So there, what is the change? Solid becomes the liquid, liquid becomes the gaseous state, then the gas becomes the solid. So these are all changes taking place where the substance changes from one state to the other, from one physical state to another physical state. Now, if we leave this for some time also, even now you all can see on the surface, the solidifying of the naphthalene. So there it is only the solid becoming liquid, liquid becoming gaseous state, and again the gaseous or the liquid state going back to the solid state. So change between physical states of matter. That is the first activity. After this, I will do the second activity where we use magnesium and we heat it in the Bunsen flame. Okay, students. So the second activity, we need magnesium strip. Now here you all can see normally we have magnesium strip in the lab. If you look at this, you have learned this before also in one of the previous lessons. There will be a layer formed over the magnesium strip. Although it's a metal, we don't see the shine. The lustrous nature is not visible. But we can clean that using a sandpaper. Now I have cleaned it to a certain extent. Now in these areas you can see the shiny nature, but it has to be cleaned a little bit more. So if you just rub it with the sandpaper, the oxide layer that is over the magnesium strip, that will be removed. So before doing the activity, we need to clean it. Right. Now you can see the shiny magnesium strip. So what I will do is I will hold it with a pair of tongues and hold it to the Bunsen flame so that you can see how the magnesium strip burns in air. We are familiar with this reaction. So we will look at that change now. So now I am going to burn the magnesium strip. I am going to hold it to the Bunsen flame. You all have to observe the change clearly. We will need to hold it for some time. You all have learned the observation, students. When magnesium reacts with oxygen, it burns with a bright white flame. We have learned that before. So here you all can see it burns with a bright white flame. So that is the change taking place there. You all saw the magnesium strip, it was cleaner. So you saw the shiny magnesium strip. Now you all can see the product after I held it to the Bunsen flame. So there you see the white color powder. So there's a complete change. Now even if we let it to cool like this, will you get the magnesium strip back? No, that's not possible. Like in the previous activity, we heated the naphthalene balls, it became liquid. Then I showed you all at the end, after some time, the liquid naphthalene became solid. But here, even if we keep it for a day or two, still we won't get the magnesium strip back. So this is a change where we burned the magnesium strip in the Bunsen flame and it produced another white color product. So with that, I will move on to the next change in this activity. So now the next activity, we will observe the change that takes place when I add a few pellets of sodium hydroxide into sulfuric acid. So here I have the sulfuric acid and these are the sodium hydroxide pellets. So this is a liquid state substance, a solution, and this is a solid state substance. So what we need to do is initially we need to take the temperature reading of the sulfuric acid solution. So that will be the initial temperature. It should not touch the wall or the bottom of the beaker. It has to be completely in the solution, that you all know. Can you all see the temperature, students? Can you all see the temperature reading? It's 25 degrees Celsius. So that is the initial temperature of sulfuric acid solution. Then what I will do is, I will add a few pellets of sodium hydroxide. Now you can see this is the sodium hydroxide pellets. When we put it into the sulfuric acid solution, you all can observe what happens, and also I have to stir it and mix it well so that the sodium hydroxide dissolves. So after dissolving a little bit, I will hold the thermometer in, and with that I will dissolve it further. So now students, can you all see the temperature has increased. It is at around 27 degrees Celsius, but still I am dissolving the rest of the sodium hydroxide pellets. So now you can see there's a further increase. It has gone to 29 degrees Celsius. Now the sodium hydroxide is completely dissolved. Can you all see the final temperature, students? So now the temperature is at 29 degrees Celsius. So that is the change that you can observe when sodium hydroxide pellets are added to sulfuric acid solution. Initially the temperature was 25 degrees Celsius. Once all the sodium hydroxide pellets dissolved, the final temperature was 29 degrees Celsius. So there you saw a change in temperature or increase in temperature, as well as you saw the sodium hydroxide completely dissolved in sulfuric acid. So there is a change taking place. So that is the third type of change. Okay students. So the last part of the activity, again we use dilute sulfuric acid and we need a strip of magnesium. So as I told you before also, when you take the magnesium strip from the lab, usually it is either coated in black color or white color layer. That's the oxide layer. We need to clean it with a sandpaper. So now I have a strip that I have already cleaned. So here you can see, if you just clean it this way, you will get it. You can just use the sandpaper and remove the oxide layer. So you can see the shiny magnesium strip there. So what we need to do is, we need to put it into dilute sulfuric acid, the beaker containing dilute sulfuric acid. You will see the change. So I will just break it into two pieces and put it into the beaker containing sulfuric acid. Observe the changes taking place. Now you can see the solid magnesium and the liquid dilute sulfuric acid solutions. So there you can see. Can you all see the evolving of gas bubbles? You all can see all around the gas bubbles are being evolved, and also you know that magnesium is usually more denser than water, so it goes down. And they are also from the bottom, you can clearly observe the evolving of the gas bubbles. And you can see the size of magnesium strip will decrease little by little. So we will have to wait till the reaction is complete. Still you can observe the evolving of gas. So there you see a change where gas bubbles are liberated from the mixture or from the medium. You can say that is the dilute sulfuric acid solution and magnesium, when they are together, you will see the liberation of gas bubbles. Still you can see it occurring. Now, if we take a large volume of sulfuric acid, and I have taken only a small volume here, if you take more sulfuric acid and even if you break it into tinier pieces of the magnesium strip into tinier pieces, when you put it into the solution, the reaction will take place faster and also it will complete faster. But here, of course, you can see the reaction is still taking place. Here, you all can see the liberation of gas bubbles. With that, students, now you all can't see that if I touch the beaker like this, I can feel it becoming warmer. So, like in the previous activity, we use the thermometer to observe the increase in temperature. Here also, if you need, you can measure the temperature, but if you just touch the beaker itself, you can feel it becoming warmer. So, there are two changes that can be observed clearly. One is the liberation of gas and the other one is the beaker becoming warmer. So, two changes. Okay, students. So, I showed you all 4 different parts of the activity and here I have all the final observations that we got from the activities. So, you can remember first we took the naphthalene balls and that was the solid. When I put it into a hot spoon, into this hot spoon, you saw the naphthalene becoming a liquid. So, there was a physical change from solid to liquid. Then I showed you all also, you saw the solidifying process, the liquid becoming solid, but now here you can see it has completely become a solid. So, from the solid we got the liquid, again from the liquid we have got the solid. So, from this observation, you all can clearly understand there was only a physical state change, solid to liquid and liquid to solid again. And also in the previous activity, when I did the activity, you saw the formation of naphthalene solid at the edges of the second spoon as well. So, there also you were able to observe the vapor, naphthalene vapor becoming the solid. So, there is only a physical state change. Then we did the last 3 activities. Second one, I burnt magnesium in air. So, there what happened? You all can remember the magnesium strip. It was a shiny silvery metal. So, oxygen of course we cannot see, but when it burns we got this product. You all can remember observing this, the white color powder. That is the product. So, when magnesium reacts with oxygen, it forms magnesium oxide. So, I have kept this for some time and you all know even if we leave it for some time or even few days, you still cannot get back the magnesium or the oxygen. So, here there has been a complete change. Initially, we had a certain type of substance. Now, it has formed new type of substances. So, magnesium and oxygen were the 2 initial substances. Now, magnesium oxide is the final substance. Then, in the third activity, sodium hydroxide pellets, you were able to see the solid pellets. This was the dilute sulfuric acid solution. Into that, when I put the sodium hydroxide pellets, you saw the pellets dissolving completely. Now, this is what we got, a clear solution. At the same time, you observe the increase in temperature. So, there again, you saw the dissolving of the initial substance in the dilute sulfuric acid solution and you were able to observe an increase in temperature. Then the last one, I showed you all the reaction of magnesium with again dilute sulfuric acid. You saw the magnesium strip completely dissolved. At the same time, you were able to see the liberation of hydrogen gas, liberation of a gas. So, in that also, initially we took dilute sulfuric acid and magnesium. Finally, you only have a clear solution and you saw the liberation of gas. So, those were the final components that were produced. So, when we compare all 4 of these changes, the first change is only a physical state change. So, there is only a rearrangement of particles or particles are reorganized so that the physical states changes. So we call that change as a physical change. If you take the last three activities, in these three, initially we had certain substances, finally we have different substances. So there, of course, the change is a chemical change. Initially we had different chemical substances, finally we have different chemical substances. So here students, you all can see, initially we had certain substances, we call them as the reactants, and they undergo changes and form new substances, and those new substances are known as products. And how did we observe those changes? In this, you were able to see the bright white flame. Then you saw the white color powder remaining. And in the second one, you were able to see the dissolving of sodium hydroxide. And also you saw the increase in temperature. Then in the last one, again you saw the dissolving of magnesium strip. You saw the liberation of gases. And also I told you all, when I touched the beaker, you can feel it warm. You were not able to see that, but I felt the beaker becoming warm. So there was a change in temperature. So the substances burning with different colored flames, then the production of new products with or new substances with different characteristics, then dissolving of substances, change in temperature, then liberation of gas, and again change in temperature. All these are observations that help us to identify a chemical change. So from these students, I am sure you all can understand a physical change and chemical changes. Okay students, so now we are going to observe different types of chemical changes. You already know what chemical changes are. What are they? Formation of new substances from existing substances. So there is the rearrangement of constituent particles taking place, or atoms rearrange from the existing state to the new state. So what are the existing substances called? They are known as the reactants, and the newly formed substances are the products. So in a chemical change, we have the reactants. They undergo chemical changes and form the products. Now this can take place in different ways. You are familiar with that. Now there are two or more reactants. They can combine and form a product. Or else one particular substance, that is one particular reactant, can be converted to two or more products. Then there is the third instance where you can have two or more initial substances which can be converted to again two or more substances. So the chemical changes can take place in three different ways, but based on that, we have four different chemical changes. So that is what we are trying to understand here. So to understand the four ways in which the chemical changes take place, I have these substances. First, I will be using the magnesium strip. We have already done this reaction, burning the magnesium strip in flame. Bunsen flame. So their magnesium strip will react with oxygen. So there we have two reactants. We will see what happens when the reaction takes place. Then I have potassium permanganate. Only one reactant. When I heat it, I will take the potassium permanganate into a boiling tube, and when I heat it, we will see what happens. Thereafter, I have two substances, copper sulfate and zinc. So again, two reactants. When they react, what they will produce. And finally, we have barium chloride and sodium sulfate. Again, two substances, two reactants, how they will react. So based on all of these observations, we will be able to classify the different types of chemical changes taking place. I'll start the reaction with magnesium strip. So already you all know students, we have done this activity before also. I showed you all previously. Normally the magnesium strip in the lab, it has a layer of oxide over it. So we need to clean it. I have already cleaned a magnesium strip. You can see the difference. The clean magnesium strip, you can see the shine. The other one, you cannot see the shine. So I'm going to use this and burn it in the Bunsen flame. So we need a pair of tongues and then I will burn it in the Bunsen flame. So here I'll take the magnesium strip like before. We will burn it in Bunsen flame. You all know the observation, students. It burns with a bright white flame. And what do we get at the end? A white color powder. So here you all can see there. So in this reaction, you all can see all this chemical change. This is the reactant, the magnesium strip. Okay, I'll show it to you all, students. This is the magnesium strip and this is the product, the white color powder. So in this reaction, you can see, students, magnesium is one reactant. The oxygen gas that is around us, when there is combustion, oxygen will be used up. So when we hold the magnesium strip to the Bunsen flame, it will burn. Then what happens there? The magnesium reacts with oxygen. So two reactants and there is only one product formed. Can you all see this? The white color solid substance. So that is magnesium oxide, that is the product. So as I told you all before, two reactants combine and form one product. So we call this type of reaction as a chemical combination reaction. So in chemical combination reactions, there are two or more reactants which combine and form only one product. So that is the first type of reaction. Then I will move on to the second type of reaction where I use potassium permanganate. So before that I will remove all these. As I told you all before, the second part of the activity, we need to use potassium permanganate, what we normally call as condis. You all have seen this. You can see here, it is a dark purple color crystalline substance, but you see it as almost like black color crystals. You are familiar with this potassium permanganate or condis. Then what do? We need to take a boiling tube. Into that, I need to take a small amount of potassium permanganate and then I will be holding it to the Bunsen flame. At the same time, we need to have a glowing splinter there. So while I hold it to the Bunsen flame, you will see there will be a change taking place and you can see it will be mostly visible evolving of gases, liberation of a gas. At that time, if you hold a glowing splinter, you will see a change. So that is what you need to observe. So here I am taking only one reactant, potassium permanganate. So here I have taken potassium permanganate crystals. So here, students, for a glowing splinter, I will use a joss stick. So incense stick, you all know. Then it would be easy for us to observe the change. You all know what a glowing splinter is. There should be no flame, only the glowing part has to be there. The splinter has to have the glowing burning part but without a flame. Right, so here I'll heat the potassium permanganate and at the same time we will insert the glowing splinter. You have to observe what happens to the glowing splinter. Now you all can see the glowing splinter getting rekindled little by little. Now you all can see, students, the glowing splinter has rekindled. You all have to observe the glowing splinter, what happens there. Now you all can see it is getting rekindled. Now you all can see it rekindles and again burns. So you all know, students, when there needs to be combustion, there has to be oxygen gas. So we use the glowing splinter. When I inserted the glowing splinter, you all saw it rekindled and it started burning. So that means there was oxygen gas evolved from the potassium permanganate. So as I told you all before, potassium permanganate, initially it is only one substance, one reactant. When we heat it using the Bunsen burner, the potassium permanganate gets converted to different products. It becomes potassium manganate, manganese dioxide, and also oxygen gas is liberated. So if you look at the product, students, now this also looks like black color powder. You all can see that as well. Earlier you saw the potassium permanganate condensate, that is purple color, more crystalline in nature. If you really look close, you will see a difference in the product that we have obtained. So here there are two substances as the products, and oxygen gas also was evolved. So from one reactor, there were three products produced. So one substance was converted to three different substances. These type of reactions are known as, or these type of chemical changes are known as chemical decomposition reactions. So then we will move on to the third type of change. So to observe that third type of change, I have copper sulfate solution here. You all have seen this or maybe used this before also. It is a blue color solution. Normally you all know copper sulfate is a crystalline solid substance. If you dissolve it in water, we get the blue color copper sulfate solution. Then I have zinc here. You can see the zinc. Again, zinc is a metal. You can see here, students, the shiny zinc metal. So I'll be using a very small piece of zinc. When we put it into copper sulfate, you will have to observe what happens there. So here, of course, we are taking two initial substances or two reactants, copper sulfate and zinc. So students, as I told you all, we need to react copper sulfate with zinc. So to do that, what I will do is, I will take a small amount of copper sulfate into a test tube. Here we can use a test tube, no need of a boiling tube. So into that, I will put a piece of zinc. I'll put this piece of zinc. Observe clearly what happens. You will have to observe the color of copper sulfate, and also you will have to observe whether anything deposits at the bottom. You all can see the change taking place, students, but it takes some time. You all can see the color of zinc plate has changed. Initially, you saw it was shiny like this. Now you can see it has turned blackish in color. The shine is not there anymore. So that means there is a chemical change taking place. The change taking place at the bottom, you all can see a small amount of solid substance depositing. Can you see that? When I shake it, you all can see it moving, and also from here, can you see at this part a reddish brown color substance, solid substance? You all can see that is copper. So you can see the reaction is taking place. Zinc is reacting with copper sulfate. You can see the color of copper sulfate has decreased a little bit, and also copper depositing at the bottom. So if we leave it for some more time, the reaction will occur further. Students, here you can see now the color of copper sulfate, it has decreased further. You all can remember it was more intense earlier. Now it has become a little bit more lighter. If we keep it for a longer time, completely the color will disappear. That also you can observe, and also you can see there the reddish brown color substance or brown color substance. So that is copper. Initially we had zinc and copper sulfate. So now there is a certain amount of copper deposited at the bottom of the test tube, and also the color of copper sulfate has decreased. That means copper sulfate has reacted with zinc and the new products are formed where copper deposits and zinc sulfate is produced. While I do the next step in the same activity, we will leave it aside. So later also we can observe the final color change. So for the next reaction, I have two solutions here, two reactants. This is barium chloride. You all can see, students, barium chloride, slightly whitish color liquid when you compare with the sodium sulfate. Sodium sulfate, you can see it is a completely clear solution, whereas you can see the barium chloride somewhat different. So we are going to react these two substances. So for this step also, I'll be using a test tube. I will take a test tube. Into that, I will take a small amount of barium chloride. And into that, I will add sodium sulfate. When I do that, observe what happens. So here, when I add sodium sulfate, you all can see, students, the solution became milky in color. And when it reacts, I'll add a little bit more. You will see it has become milky in color. And if we allow it to stand for some time, we will see a white color substance depositing at the bottom of the test tube. So here we used two reactants, barium chloride and sodium sulfate. Now there is a chemical change taking place. That is why you get the whitish color or milky color solution. And in that, there is the production of or formation of barium sulfate and sodium chloride. So as I told you before, there are different ways in which the reaction takes place. When we take more than one reactants, there can be more than one products produced. So here, barium chloride and sodium sulfate, they form barium sulfate and sodium chloride. So that is known as a double displacement reaction. So with that, I told you all we will leave the solution to a side. Again, I told you all I will show you all this one. Now can you all see, students? The color has become more lighter and you can see the brown color substance at the bottom, deposited at the bottom. So this reaction where we used copper, sulfate and zinc. Two reactants, it became zinc sulfate and copper was deposited. So their copper was displaced by zinc. Therefore, we call that reaction as a single displacement reaction. And after that, what did we do? We did the reaction between barium chloride and sodium sulfate. And I told you all the products, barium sulfate, that is the white color powder. Right. So normally, students, when we use a very large amount and if we leave it for some time, then you will be able to see the white color solid depositing at the bottom. But at least you were able to see the color change. This became milky in color because there was the production of barium sulfate. So barium chloride and sodium sulfate form barium sulfate and sodium chloride. So that reaction where we had two reactants and two products, and that particular change is known as double displacement reaction. So we observed 4 different chemical changes. In the first one, you all can remember, students, we used magnesium with oxygen. When magnesium burns in oxygen, there is magnesium oxide produced. So that reaction is known as a chemical combination reaction. 2 or more reactants forming one product. Then the second reaction, I don't have the products here. We use potassium permanganate, one reactant giving rise to 2 or more products. I told you all potassium manganate, manganese dioxide and oxygen gas was evolved. You were able to see that. The potassium manganate that remained in the boiling tube, potassium manganate and manganese dioxide, and we use the glowing splinter to observe the evolving of oxygen gas. So from that you all know, from one reactant, 2 or more products are formed, and those type of reactions are known as chemical decomposition reactions. Then the third one, that is what I have here. We used copper sulfate and zinc. So there are again 2 reactants, but there the zinc displaced copper. So there was only one displacement, therefore we call it the single displacement reaction. And finally, I did this reaction between barium chloride and sodium sulfate. Here, of course, the products are barium sulfate and sodium chloride. So this is a double displacement reaction. So those are the 4 different types of chemical changes taking place. The chemical combination reaction, chemical decomposition reaction, single displacement reaction and double displacement reaction. So I am sure now you all can understand the 4 different types of chemical changes taking place. Okay students, so now I am going to do this activity again to observe another chemical decomposition reaction. We already observed one reaction, that is the decomposition of potassium permanganate. On heating, potassium permanganate decomposes to produce potassium manganate, manganese dioxide and releases oxygen. So here I am going to do another reaction, that is with hydrogen peroxide. So here you can see students, it is hydrogen peroxide. Usually at room temperature also hydrogen peroxide can decompose slowly. So to prevent that only, we store that in brown colored glass bottles so that the sunlight does not penetrate in and the reaction can be prolonged or prevented. So now what I am going to do is, I am going to take a small amount of hydrogen peroxide into the boiling tube. We will need to heat hydrogen peroxide. So here I am going to take a small amount of hydrogen peroxide. Then we need to heat it. So I am going to heat this hydrogen peroxide. You all have to observe clearly students what happens there on heating. You all have to observe. Can you all see the formation of gas bubbles at the bottom? There from the bottom you all can see students. Now when we heat, can you see the gas bubbles evolving? So here you all can see students the evolving of the gas bubbles. That is oxygen gas. So on heating, hydrogen peroxide decomposes, it undergoes chemical decomposition giving rise to water and oxygen gas. So that is the chemical decomposition of hydrogen peroxide. You all can see the gas bubbles there. This is another reaction students, a chemical decomposition reaction. Hydrogen peroxide H2O2 on heating gives rise to H2O water and O2 oxygen gas. So another example of chemical decomposition. Okay students, so now we are going to look at a few single displacement reactions. So you all know in a single displacement reaction there are 2 reactants. One is an element, the other one is a compound. And the element displaces another element from the compound. And finally, in the products also, you get a compound as well as an element. It can be a gas that is evolved or it can be a precipitate. So we will observe few reactions like that. To do this activity, I have copper sulfate solution, magnesium strips and hydrochloric acid solution. So first what I will do is I will take a small amount of copper sulfate into a test tube. So here you all can see clearly, students, you are familiar with this solution, the light blue color solution of copper sulfate. Then I have the clean strips of magnesium. Here I have already, you all are familiar with that. Normally the oxide layer covers the magnesium strip. I have cleaned it now. So I have a few pieces of clean magnesium strips. So I'll be using that for the activity. For the first one, what I will do is, into this copper sulfate solution, I will put a clean magnesium strip. We will observe what happens there. So when I put that, can you all see the liberation of hydrogen gas there? Students, can you all see the reaction taking place? There, copper sulfate reacts with magnesium strip. So that is how you can observe the reaction, and you can see some solids going down and depositing at the bottom. So that is the reaction between magnesium and copper sulfate. You can see the reaction taking place. What I will do is, I will keep this aside. I will do the second reaction, and again finally we will observe what happens when the reaction completes. So here you can see clearly, students, the reaction taking place between magnesium and copper sulfate. You can clearly see the changes taking place. So I will keep this aside, and then we'll do the second part of the activity. Here I'll take a small amount of hydrochloric acid solution into this test tube, HCl solution, and into that also I will put a piece of clean magnesium strip. So when I here again you can see the reaction. This is the evolving of hydrogen gas. You can see the liberation of a gas there. Can you all see it clearly? You can see the reaction between magnesium and HCl, and you can see the liberation of a gas. Evolving of a gas or liberation of a gas, you can see that clearly. Can you all see that clearly, students? Here, if you look closely, you can see the liberation of gas. So that is the hydrogen gas. So again, if we leave this for some time, you can see the complete reaction would have taken place. So I will keep it on the stand. We will observe the previous reaction again. As I told you, students, I kept the two reaction mixtures. One is the copper sulfate and magnesium. The other one hydrochloric acid and magnesium. So now I'll show you all the observation. Can you all see here, students? Can you all see the color clearly? At the bottom, you all can see the brownish color precipitate. What is that? That is copper. So when we put magnesium into copper sulfate, magnesium displaces copper. So that is why the color of the solution also has decreased. The intensity of the color is less now. That is because copper has been displaced from the compound copper sulfate. So the reaction between copper sulfate and magnesium is a single displacement reaction. Why? Magnesium displaces copper. So I am sure you all can observe the changes clearly. The same way I told you all, now in this also, now you all can see at the top you can see a very tiny piece of magnesium. I put a small piece of magnesium into hydrochloric acid. You were able to observe the liberation of hydrogen gas, and still the magnesium is reacting. So there are magnesium plus hydrochloric acid. Those are the reactants. Magnesium displaces hydrogen. That is why hydrogen gas is evolved, and in the solution it will be magnesium chloride that remains. So this is also a single displacement reaction. Magnesium with hydrochloric acid giving rise to magnesium chloride and evolving of hydrogen gas. So when the reaction completes, it will be only magnesium chloride solution. Unless there is excess of hydrochloric acid, there will be magnesium chloride in the reaction, the test tube, and also the hydrogen gas has already evolved from the test tube. So both these are examples of single displacement reaction. So before that students, I showed you all the reaction between zinc and copper sulfate. That is also a single displacement reaction. So we have observed 3 types of single displacement reaction.